Hello, good morning. My presentation is related and unrelated to the previous presentation. I will tell you how you can reverse any device that you come across with or any other thing. Okay, this is about me, but I feel that this is not relevant for my presentation, so I'll go right away to the content of my presentation. Brief introduction, then we will talk about IoT devices, how they what they are about, and then initial status about the analysis about the embedded chip ESP8266, then dumping firmware, and then how we can analyze that dumped information. Then I will tell you how to analyze that firmware by using shared tools and what we get out of the image format. All this started after Black Friday. So a friend of mine said, well, I have lots of devices at home, IoT devices, I can switch on and off the lights. And I said, well, it is also voice operated through Alexa. And I said, okay, I will try it on myself to see how it goes. So I'm appealed by this device here. It is just a device that captures IR signals and transmits them. So any device that you may have at home, a TV set or air conditioning, you may capture sequences and you may repeat them through this device. Then you go and tell Alexa, please switch on the air conditioning. Please turn on the blue light at the dining room, and does that for you. All that is done through applications. I'm sure you're aware of this app. It is Smart Life. Well, actually, the name of the company is Tuya, Smart Life. This is an IoT device company of low cost. So if you go and say, I want to manufacture, or you to manufacture for me a board that kind of switches on LED light, and then they develop that app for you, mobile app for you to communicate with Alexa, and for Alexa to communicate with those devices, you need to download skills. So the skills are just gateways within in your Alexa account that allow you to control the manufacturer's device. Once you have the Alexa Smart Life app installed, then you're going to say, please switch on the light. The life is switched on fast, but take a look at everything that happens underneath that. When you're going to say, Alexa, please switch on the light, then that is sent out to Alexa Cloud, then the interface takes a look at it to see whether there are skills. The skills communicates against the device, well, actually against the cloud of the device manufacturer. And now, through the manufacturer's cloud, it communicates back to Alexa Cloud, then it goes back to your home, and now the manufacturer switches the light on through talking direct with your device, which is an ongoing connected to the manufacturer's cloud. And then I go and say, look, if I am at home, why Amazon should be aware that I just turned on the light bulb, and why the manufacturer should know that I am in my local network. There is a difference if I am in Germany and I want to switch on the lights of my home in Alicante. But when you're at home talking to Alexa and telling Alexa to do this or that for you, I find it absurd that this type of communication is the way it is. Now I'd like to tell you a bit more about IoT devices. I just want to give you some background and for you to know what happens when you give a command to Alexa or to any other. IoT devices, the ones that I tried were the RM3 Mini, which is just an IR emitter. Then I also have like LED RGB strips. This thing here, I've taken out the wires and cables for the firmware, and well, you have this LED strip at home for some nice light. I started off with RM3 Mini. The thing is that I ruled it out because there is a project that allows you to control it locally. I didn't want to research on something that has been researched before. I have this LED strip as well as a smart set of plugs. And for that, there is a Tuya API. That is a project that allows you to control those devices remotely. Yet you lose connectivity with your mobile app, etc. It goes through Python skills, and you need some kind of configuration. This is Tuya API. It is a library for communicating with devices that use the Tuya cloud network. So if your device has the 668 port open, this library will work. But then you need to know the ID of the device and the key. And so where does this device come from? And this key, if I want to work with this, why can't I plug it in my home at home and say switch on and off, and asking it to switch on and off itself? Well, Tuya API tells you that when you configure the device, you can implement man in the middle to see how these keys are being exchanged or transported. But I just don't like that, because I need to rely on the good performance of this method. And then a few days before I put together this presentation, I visited the website, and it tells me that it was already deprecated. So now let us start off with the initial analysis. This board I disassembled, and I found this board. I know nothing about electronics. I know about PCs. The only thing that I know about electronics is the Arduino or some CFTs that I took part in, where we were given a device for some reversing, and that was it. So this is ESP8266. So from the M1 references on top, I just found this photograph saying M1, and then you can see this is what I did with it. I disassembled it. So nothing more than ESP8266. So this device is a low-cost one, and performance and features are quite interesting. CPU RISC of 32 bits. It is based on Tensila Extensa, so 64K RAM. It supports the protocol IEEE 102.11. It also supports web WPA, WPA2, and also very important, it has 16 pins. You can control 16 outputs, whether it is LED or whatever. So it has 5 GPIOs activated. So as you can see, these are the specifications for this ESP. When you see that, well, then I found the ESP tool. This is a tool of the manufacturer that has been developed in Python. So here I know that I can dump the image or flash the image. We should not forget that ESP devices work at 3 volts. Our USB often work at 5 volts. We have to be careful. We need a UR converter that converts into 3.2. USB to TTL can be found at AliExpress at $1.3. and if you want to have it home the next day, you buy it on Amazon. I recommend, if you want to do this, buy a few of them, because they are only 1.3. You don't know what the frequency of the crystals inside. It might not work when you try it. So it did not work for me up until I bought the one that you will see here below. It was for 5 volts. I just removed the button, and then this is the speed that I used. 6,000 baud was not enough. And then I said, oscilloscope. Well, we checked the signal, and I said, I don't have that. I don't have an oscilloscope. Just for a device that was 12 euros and to give a presentation, I'm not going to spend 600 euros in an oscilloscope to measure, to gauge the signal. And I say, well, tell me about the USB and TTLs that you use. I ordered them on AliExpress and they worked for me. And I said, look, I didn't need the oscilloscope eventually. So he continues to say, buy the oscilloscope, will be a good investment for sure. So as I say, it is interesting that you use or buy a development board. I don't know whether you can see that right or not. So I'm referring to this board here. The Wemos is even smaller than that. It is linked here, just don't want to move it a lot. This is the board. I'm holding it now. It is exactly the same as this one. Notice the size. ESP8266. This development board allows you to, you don't need to use the USB TTL because they already have an embedded USB circuitry, and then you connect it to your PC. But when we go to physical device, when you use a physical device, this is the board that I showed you before, we need to identify. This is not very difficult because we have the drawing next to it. We have mass and IOS ports are exactly in the same positions, RX max and this voltage pin. It is here so that for easy flashing of these devices, we need these lines. We really want to read these lines. This is the welding thing. I have to thank my girlfriend. She helped me doing this welding. I did that welding. Then the mass cable, I also welded it just in case we needed to use a transformer of 20 volts, etc. And then here on top we see the GPIO1 connected here. GPIO is used for bootloader mode. When you are using this development board, you just plug in the module. When you say that you want to upload a firmware, the TLS sign goes to mass, and then it does the physical bridge that you will need to do yourself. So if you want to enter into bootloader mode and to program it, this is the device that I show you. Once you have inserted your own cables, you may close it and it looks nicer. So this is the USB TTL reader. That is the device. Everything is connected, and this is a development board. If you want to go into bootloader mode, you will have to drop the GPS1 to mass, which is this white table. If I want to flash or to read this device, I will have to drop it to connect it to mass. This is what it says on the ESP tool website. If you need to use the bootloader mode, JPO2 is held low on reset. It's very easy. You only need a small wire, and then you just plug in the white one with the black one, which is mask. And now we can dump framework. For that we use ESP tool, which is quite simple command. And then about rate, I'm very patient, and I say, well, if it reads it, perfectly all right. And then you ask it to read from 0, and then you also tell it the amount of memory that you wanted it to read for you, and then at the end you give the name of the file, and then it says, well, this is everything that is read. I did all this writing on the development board. So this is the writing, and then the file is rom.bim. Now we have our ROM. Now let us see what's inside, because I'm interested in finding out what happens inside the ROM interaction in it. I open it on the hexadecimal editor, then I look for strings, and then I can see that there are text screens, things that remind me of code. Then I see structure in a format, specific format. Then when I start to document myself about the architecture, doubts are cleared. To me, I know nothing about ESP8266. There is a really nice book called Man's Book on ESP32. This is a free document, a free booklet, and it explains very, very relevant things. To use this, we will be using IDA, but IDA is not aware of extensa architecture. But some people at IDA have came up with a plugin that allow you to use extensa architecture. And IDA does not recognize the format of the dumped image. So this format, you want to know the format because you have to tell either this goes in this segment, this goes in memory, and when you do that, we will have the cross-references that will help us a lot in our analysis. Image format in the ESP tool tells you it only starts off with, always starts off with 9, then you have the segment, then it also tells you about the board, segments, entry point. 4 bytes standing for the entry point, and then the number of segments. Within each segment, we see segment 1 starts off in memory position 40001000, and then it measures this amount of bytes, 400, 500, and that is multiplied by the number of segments that are in the field. So you have a segment, the first 4 bytes tells you what in the memory that is mapped, then the size, and then the data that you have to enter in that memory slot. That is quite easy. They have the version 1 and version 2 format. Version 2 format is similar, but the number of segments does not match with the number of segments of version 1. To work out with that device and to get right image, we really need to find out about the internal operation of what happens inside. We see that in address 3FFE, we have DRAM. In 40000, we have boot ROM, which is run at the beginning, and then address 4010000, we have the IRAM, and then in 4200000, we find SPA flash. What is APA flash about? It was hard for me to understand, but once I got it, gave me a key to set up the framework in the memory. You have read 1 mega of memory, but in the 40202000, that mega is mapped right down to the end. So we have the memory description, but all that will be set up in the memory, but the whole memory has been mapped in 420000. I didn't know at the beginning, and then when I used to disassembly and to set up all the memory segments, and I said, where does this 40202000 comes from? Did I skip some parts? Is there an SPI somewhere else? And after reading the Commons book, you can clearly see it. It says that this is done because of a speed issue, because that area is easier to access than any other areas. And well, as long as we know what each of these memory addresses contain, it's in just as much as we need to analyze the disassembly. The manufacturer have or offer the OTA upgrade, that is to say, updating the firmware without having to connect any cables, nothing. Some developers can only know how to program. They just get an SDK and program the device. That's it. So when we do not have an OTA, that is to say, when we cannot really flash the device through network, this is how it is mapped after dumping. We will have the 0 address, we have the user application, the address 3E000, we have the master device key being. In 40000 we have 240K, which is the SDK. This is offered by the manufacturer. I don't know which version of SDK is about. That has helped me out a lot for me to interpret it. And now we have the configuration when you use OTA. That is to say, when you allow upgrades. So that bootloader will boot the user application. When you want to upgrade the board, the bootloader will launch the application in slot 2, that is to say, the one flashing data, that will be recorded on slot 1. Therefore, it will be rebooted. That is to say, a new firmware has been recorded hot without having to use any USB devices or anything else. So we have a bot bin. The bootloader will upload the user application, either 1 or 2, depending on how the device is booted. And it also has a SDK library. So this is what we would need to do. So we have created 2 scripts, one for loading the ROM loading, and then for the extensa architecture. The first thing we have to do is to parse the user code to that very same memory address. We will need to map at 0x40000 all the content that we have dumped. And because we have these files, Eagle, ROM, ADDR, V6ID, we will be having the basic API on USB. So these are the name of the functions. So these are the most basic functions of the system. Thanks to this file, we know that everything that is at address 40.0.2000 can be given addresses, because we are talking about fixed functions. So we also need to do some fixes, because the image that has been read has to be mapped in the segment 40.20.000. If you get the script that I showed you in one of the first slides, you will have to add these functions to invoke them, and then the image will be perfectly generated. You say that the segment is 1 mega, you call that payFlash, you said that it is a code, and I said from the 0 address, please map it there. It has mapped the segment in 40 to 000. Then I will jump all the well-known functions or the known functions. Then my function is made internal. So well, in 4700, this is the name of it. In 46 is for 8, cache enabled. So by the time you will open the memory, some of the functions will already be identified. And then I will create the segment for the IROM, 40,000 plus the code. Then I ask it to create that segment for me and to do made internal, so that all the names are put in that segment. So you will see that when you call the function, that was the name of the function. As long as you have the function, you don't really need to see the code. Then the format 2, you want to use that to create the real functions. Load file. We order it to parse the section, and well, you copy this script, and loading will be perfectly right. Well, there is a loop in that loading script. When sections are mapped, are done that in file offs. So this is mismatched in 8 bytes. So the solution is offset plus 8. Once you move your ROM towards IDA, it is rightly recognized, and it says from 0 to this number we have a section. Then we have the ROM data from 3FF008 down to this user data that has been defined from the segments that we've seen. It has mapped everything has been mapped. The only thing that we have done is to introduce the SAP flash, because all the memory has been dumped, and now we are adding the dumping, and we have the perfect image. If you want to take a look at strings, find strings, you will find strings, no problem. If we go to call any of the functions, perfectly all right. There is a reference there. As I could see offset 42, and I couldn't see anything, and I said, where does this information come from? What is happening here? As I said, well, the booklets that I told you before, I was not very happy in the beginning, but I made an effort to typing my email address, and then I got that booklet for free and gave me the answer to that I just didn't get. So there is no flirt here. So we have thousands of subs that have been done in an extensive architecture you don't know anything about, and you don't know what it does. And then you go and say, how can I analyze this? How can I get anything relevant out of this? And this is what I want to show you how to do it. That is to say, to create a database and to fix this problem. And I said, well, people write code for that. Well, I'm sure there will be an SDK to be generated, and then to start writing code, compiling code, and understand it. If I enter the code, I know the structure of it, the assembly of it, and then I say if I use the very same SDK or a similar SDK, I will come out with very many similar functions. So I will try to take a signature, generating a similar SDK. So I take a look at the screens, and I see that it uses this version from the 25th of January. So they use two SDKs, the one from Tuya and from the manufacturer, plus the other features that they offer to their clients. Then I take it from there and I use the SDK R2 from Expressive, and then I need to find a way to generate code. There are ESP8266 was not as dark as it used to be 4 years ago. In the past, information was only offered in Chinese. This is a Chinese company who manufactured it, whereas now those libraries have been exported to Arduino. Arduino supports it, but Arduino, as far as I know, that they do not use the SDK version 2. They use Nonos SDK. One is more for the operating system, the other one for code patching. Expressive has a SDK, but a bit of an obsolete or old. So if you give me a main file, I just don't get it, but some of you understand it perfectly right. So it's a script with no binary code, therefore I don't understand anything at all. Expressive SDK was not for me. I just ruled it out. I just didn't want to learn anything new. Then I went back to James and they say, Platform IO, please use it. So it has an IDE, has a debugger, and had many tools that are great for generating code for this type of devices. So Platform IO is a plugin for Visual Studio Code. You download Studio Code, then you go to the section, you say that you want to add Platform IO IDE, and that's it. It is installed and ready to operate. So we will be entering our pieces of code to disassemble it and to see how the level of match with that of the manufacturer. So it is good that you have a board for that. So this is SPE12E, and this is the framework, ESP8266R2. Oh, great, this is the one that I wanted. And they also have the Arduino one. Once you configure the project like that, as of now, you create user main.c, and then you start to enter code. I want you to be clear about this. Platformio manages libraries, and then so this is being cut, this is embedded, there are no libraries. This is what James answered. And I said, well, how can we inject anything here? Well, perhaps this is not big thing, but I didn't know about this platformio.ini file. And then with build flags, which is very common or standard in Unix now. So with option -L and the library that you want to use, you use it. But TLS is used for communication. And you can see that by analyzing the ROM strings, and then you see that the actual development kit of Expressive comes in with that library for you to use it. So the complicated part here for me was how to add it. If you ever have this problem, you should know that platformio.ini will help you to add the flashes. If I want to identify functions, well, I really want to know what the device can do for me. Can connect to Wi-Fi, to send data through socket, being a client socket or server socket. Also stores information when you switch off the light, when the device reboots itself. Power goes back. So data that are received are persistent. So there is some kind of a file system. We also know that. So SPIF is quite of a file system which is quite light or lightweight. It is a very light archive or file creation system. We see lots of JSON strings in this firmware. Well, so JSON objects can be created as well as transmitted. So this is a feature that which is interesting for us to recognize the functions that are generated. And then we also know that a GPIO has to be generated to modulate the light of LED. To identify functions, so, well, I will create strings and see all the .c's there. So firmware is secure. So they have ensured that you cannot really see the code. And there are some debugging messages that tells you what you're doing exactly when you're doing it. So because we are aware of the functions that will be used and then also the name of some Cs, then we go to the sampled folders of platform EO. So you find that in your user folder. Here you have the framework. For each of the framework that you may install, you have your ESP8266. These are examples from the manufacturer: OpenCeller, Smart Config, Speed, Wi-Fi Station, WebSocket Demo. What do I do there? I take them all and I put them in huge projects and compile everything, and as I will have wonderful signatures for everything that I may need. We add several of them to the user main.c. But careful, the memory is not infinite. I had to do an example with a Wi-Fi part, with a socket part, client socket, server socket. I went module after module to take out the signatures. This is the ordinary ELF file. The only difference here is that ELF file is in extensa architecture. Once you have compiled it, launch it into IDE, you have the names of the functions, and then you can also see the code that has been generated in extensa for you to use it as a reference and to take out signatures. So this is an ELF file created by me. I just took an example of accessing JSON, and this is the entry points of the program. We have the debug vectors, and then we see where all the functions start. We just don't have sub. We have JSON create, JSON print. We do the same thing with everything. And then how can we transfer this information to the other database? It's a feature SIG-made for you to compile a library. The information that you use to compile the library generates a .pat file, and the file has the heuristics that you need to find the byte pattern that you need and to associate it with the name of the function. But for extensa signature, you cannot use a DL of an ELFI and to do that for you. Yet, people of FireEye, more specifically Flare team people, have a script in Python, and if you have a database created in IDE, you may export it to a .pat file to take out these signatures, to extract these signatures. So this will generate a PAT file that will go through SIG-make, and then it will return a .sig file. Then you load it, and if you are lucky, you will have all the functions. So that's all you need to do with that plugin. You parse your database, and it will generate the .pat file. So we have the JSON.pat, JSON1.sig. If detected as same version, it creates a DRR file, and I say, look, add plus sign if you want to use this one, or remove this comment. So that is clearly explained at IDA documentation. Once we have our SIG file, we need to create a SIG directory within the IDA folder, and within that SIG folder we need to include Extensa architecture. These are all the files that are generated, ESP, A266 for it to recognize all the general functions, SSL, speed, JSON functions. Then I go to my signatures, and now I can use these signatures in any project of this kind. When we use IDA to open that, because now we have a loader, knows how to interpret this file because it has read the mark of the dumping that we made. So I told you that it would start reading in section 1000. So you can cut and copy and paste it. So this is the plugin that we have installed to loading it. Then we go with SIG to the signature window, and we see all the functions that have been generated for this device. We select them, and then we will be getting a database which is easier to read than before. This comes from the device that we have flashed. Notice what happens on the left. Functions are no longer sub. Only from name I can see what each of the functions is doing. If someone calls me to create a JSON, I know it will create a JSON. And from there you have full control, because this can be improved a lot, because the method that has been used is not heuristic. If we get it right and we use exactly the same version of SDK, I didn't use the same one. They used the 2.0 version compiled on the 29th of June. The one that I used was 1.5. The functions are very, very similar, and if they are not exactly the same, can be easily identified, because you know when the function is put in a code, all the JSON functions will run after the other. The same goes for socket function. So it is in good order, and it follows a logic, and we can use that to our favor. If it replaces R0 with R1, the signature is not there, but mob R1 or R1 a different value, the body is still there. You can do some heuristics to detect it, and if not, you just detect it by looking at it. I also, something else that I do is to look for the values of T1 or the CRC values or the values of MD5 in it. What about time, Roman? Oh, I'm doing really bad. Well, Diaphora is the program developed by Josean for recognition of signatures and malware families. You could do something similar to this. You could automate that. Well, you need an infrastructure supporting you to do that. All right, so I will go faster. Once I have the firmware, well, I told you how to set up a database, how to extract coherent or consistent data, and now you need to analyze the database. What was the result of my analysis? I could see that devices have an encrypted file system. They communicate with TLS PSK against the manufacturer's server. They implement MQTT, devices implement MQTT clients. Devices have an activation system. You get any of these devices, you try to plug it in, and if it does not communicate with the firmware of the manufacturer, it will not start itself. Devices have a security system to avoid clones. If I record it here, it doesn't work. Well, it works if you know if you can identify where the anti-cloning measures are. And devices have telemetry, send out telemetry about everything that you send. So every single minute the devices talk to the server. They can be remotely flashed by the manufacturer without no one noticing it. If we wage a war against China, well, they have done half of the work. Well, encrypted messages, the key has been hard-coded. They use AS128 CBC. It's modified with a MAC byte. No one will break that. I have the key base. I can brute force 1 byte, which is a bit funny. And now I can read this device physically, and then I can get the key from your home or from the internet. I brute force that, and it takes me 15 seconds. Well, I have a Python script that does that for me really fast. TLS PSK 128, 256, no certificates are used. Shared key is not hard-coded. They decided to use an algorithm. Funny, isn't it? Communication in clear text. I have the key to it of my device, and then I can also get anyone's key. It is okay if you put a key, but please do not give me the algorithm that generates keys for the whole world. I just need to do some reversing to get the keys. MQTT web clients and telemetry. What can we do against that? Well, everything goes through TLS PSK. Once I have the shared key, I can take a look at all the traffic that has been used. I can prevent telemetry from reaching them. And then anti-clone security. That is based on MAC address, but also in eFuse values that are unique per board. If you have the original board, you dump those values, and when it comes to reading the code, instead of reading the code, you hard-code it, and that's it. So this is what happens with this device. This device is exactly the same as the other device. This has been cloned, but this one returns exactly the same MAC than this one, same as the same eFuse values than this one, without even having these eFuse values, because the code has been hard-coded. Conclusions. I was about to show you a demo, but I'm not going to do it for you, just to see how an LED switches itself on. Conclusions. Security, yes, manufacturers have implemented a number of security measures, all of them insufficient. If you have a device where you cannot prevent someone from dumping your ROM, well, code obfuscation make it a bit difficult. It is the first time that I'm working with extensive architecture. It has been relatively easy for me to get an IDA database. They should never leave or give an algorithm, a PSK algorithm, on the client, and they should never use a hard-coded key. even if it is generated in the memory. They do that for you not to see it, and they change the byte. But if you analyze the function and you see how it moves, and you can get it. So my initial objective was to locally control this device. How do I do it now? I no longer have a problem. I can read the configuration of the device, the information that you have in internal memory, and then the servers that it is connected to. I can change that to my local IP. I know that it communicates with MQTT and PSK, and I have the keys. Nothing prevents me from setting up this architecture locally. Once I am there, because I will create a front end, and every time you connect to port 80, it will say that I am this client. It will give you the SSL key, and I will connect to my server. All my traffic is in clear text and nothing else, no other secrets. This is no secret. So use of knowledge to do evil. So you need to know the name of the Wi-Fi and the password. When you start the device, then it flashes. There is a flashing light and says in mobile application, and then you send data to mobile app. Everyone can see the data transfer. Because I have this device here, this small device here, notice that the size of it can be reduced down to this with a 3-volt battery. Then you leave it at Greg's home. I just leave it at his home, and I trust that he's got one of these devices, and if not, I just give it to him, and I say, Greg, okay, use this LED strip at home, it's wonderful. Then he configures that, and I leave it there, and I come back in a week or in a month. It is also in pair mode, but this one removes the servers so that we don't connect the 2-year servers, okay? Then by the time he will pair devices, then I will have the information. Then I will go back to his home because I have access to the flash. I read the Wi-Fi, I connect to SSD, I connect to his home, and then I will use everything, and then I will inject my sniffers, my everything, and that's it. So it's wonderful for red teaming. End of the instruction. This is so small, and you can make it smaller. So it could be as small as a 5-cent or a 2-cent coin. So I wanted to show you a demo, but I just don't have any time left. I would like to thank Marta, my girlfriend, because of her patience. Sometimes I become a zombie at home. She allows me to be a zombie. So the man of oscilloscope, Jorge Linares, tried to explain the LSPSK concept. I understood the concept, but I just did not understand how to program it. And then, well, at the end of the day, I kind of together with Chrome, I understood how TLSPSK is about. Michael Steigerwald told me how to use framework. So they spent lots of time to me. They gave me scripts that they had developed. Where BLC, part of Tuya Convert and Tuya API. My former boss, he told me how PWM circuit was about. I would like to thank RootedCON, of course, for inviting me one more year, and to all of you for being here, listening to my presentation, even if you are very hungry now. So thank you very much. I know that we are all hungry. How many questions do you have? Please raise your hand. One question. to identify functions, what do? Preambles, and then did you mark them as main function? Well, I didn't need to do that in most of the cases because IDB2Pass did that for me because I had a database with debugged information, then it took the signature and created it. Yes, sometimes the functions are very similar. The preamble is very similar, the post is very similar, for registers are changed, or records are changed, and well, you have to do that visually, so to speak, to end up with a decent database. Those of you who have other questions, please raise your hand or please stand up so that we can see you. Okay? 2 questions. You said that you used SDK 1.5, whereas the firmware used the 2.0. Did you try to use Diaphora to see the differences between the two of them? No, I didn't use Diaphora because I was doing it very fast just to testing it. I think I told you that Diaphora could tell you about the differences. I would try it out in the future. I didn't do it because I just don't have experience, and as I say, well, sorry, I just don't want the developer of Diaphora to know that I don't have any experience with it, but I've just said it. So I would like to ask David question. Is David ready to ask a question? Answer the question. Well, you said that this device has been thought for criminals. So I would like to ask you whether you did not take into account, especially when you told us that you wanted to sell it. What about the penal code, Article 176, that tells us that the manufacturing and the sale of software aimed at committing crimes, as stated in Article 176 of the Penal Code, did you take that into account? No, that was a practical joke. I was not serious. I said ethical hackers. If that device, if the one and only purpose or application is committing the crimes established in Article 176, you may have problems there. Well, my question, why is it a crime? What happens if the CNI uses it for one of the operations? Okay, well, that is my question. It is a tool, same as any other, with a purpose. There is a purpose to it. Any other questions? So, no, hold on. There is one more question. Is there a way for me to replace the ROM that comes with the equipment to change the signature so that it wouldn't be so easy for you to do the signatures? Well, with Diaphora, if similitudes are found, well, how many knobs do I have to introduce? No, it's not a question of knobs. As long as you do obfuscation or you say, oh, cipher or encrypt the code for me. But David is a comparator of the product. He wants to do something bad for it. Perhaps he wants to obfuscate the ROM. What can you do with it? Do you take it out? Do you replace it? Hold on, I need to explain something there. This is like that because for SAT, it is more convenient to make the ROM accessible. I can toast the ROM so that you don't see it. Perhaps a couple of thousands in the Middle East would can extract what you have protected in the flash. But the typical hacker with on a low budget couldn't do that. If I program the fuses So they do it because it is convenient for them to dump the flashes, but at the end of the day you are going against yourself. So if you just don't let to see the fuse that allow me to read it makes me reprogram it, and I don't know what the failing is. So this works like that. This is not protected from reading the flash. The flash is open to read, but then I can program the fuse, and then using that the EPROM can be read with this very expensive microscope. Yes, Eduardo gave us a presentation about having that, and Eloy also does that. But if you just put the fuses, you cannot see anything. So these devices are like that because it is more convenient for them. For you, when you want to make money, you really need to have a medium level of security. I just don't mind because I just do it for red team people, if you know what I mean. So at the end of the day, I don't mind, okay? Uh, all right, so thank you very much for your great presentations. You are really big. All right, take your time for lunch. Well, apologies to our next speakers. We will try to adjust time for them.